What's up, you guys? So in this video, I wanted to discuss the concept of standard deviation, and in a upcoming video, I will also discuss the concept of standard error, they're closely linked. But with standard deviation in data science tells you how spread out your data is. So oftentimes, it might be more beneficial to have data that's not very spread out, perhaps more spread out, but basically standard deviation tells you, if you have an average, how spread out was your data when calculating that average. Did you have an average of, let's say, 10, and you had two data points that were 9 and 11, or did you have an average of 10 and your data points were 1 or 5 and 15? So that would have the same average but two different standard deviations. So standard deviation basically just tells you how spread out your data is. So in this video, I'll talk about standard deviation by connecting it to a closely linked concept of variance. But before we get into that, I wanted to discuss this. This is called a normal distribution graph. And so it shows you what percent in a normal distribution of, let's say, grades in a class. Let's say 100 students take an exam and the average was a 75. Or better yet, let's say we have tons of humans, tons of men on this earth, and the average height of those men, is about 5'9". Let's say 5 foot 9 inches. So that's the average height of a man. But the thing is, men don't just fall under that height, they fall under 6 foot something. They fall under the low 5 foot range. So this is just the average. But standard deviation tells us how spread out are we from that average. And so if you are considering men who are only within one standard deviation of that average, you will see that about 68% of humans fall within one standard deviation. If you go two standard deviations, that's about 95%, I believe. So 95, so let's say 95% of men fall within two standard deviations of that mean, of that average. And by the way, average in statistics, we represent it with X bar. So that is the mean, the average. So 68% fall within one standard deviation, either one standard deviation greater or one standard deviation less than that average value. And so two standard deviations we have now are encompassing 95% of the population. Three standard deviations we're now encompassing close to 99% of the population. So we can kind of see if there is an overlap between two data sets, if they have standard deviations that kind of fall within each other's ranges. But that's generally the normal distribution with the standard deviations. So now that we generally understand standard deviation, we should figure out how to calculate it. And also, by the way, if your data is more spread out, so if we look over at these two pictures here, if data has a high standard deviation, the graph might look like this bell curve might look more spread out. Whereas if the data has a low standard deviation, that bell curve would probably look like this, where you have more data points nearby that average rather than further away from that average. So again, standard deviation just tells you how spread out your data is. High standard deviation, it's pretty spread out. Low standard deviation, they're pretty close to the average. But let's figure out how we calculate this, because that's something you need to know for the exam as well. And so before I get into standard deviation, I want to discuss a closely linked concept. So let me see if I can get that glare out of here. I'm not sure if I'll be very successful in that. Okay, good enough. So a closely linked concept that will lead us into standard deviation is this concept of variance. And again, variance shows how spread out the data is in the same sense. But this is the calculation for variance. So variance is s squared, and variance is equal to the sum, so this is a sigma symbol, it means the sum of the whatever data point, some data point, or each data point, minus the mean, the average, and we square that to get rid of any negative values that we might get, and all of that over the number, or the size of your sample. So if you took 6 data points, it's 6 minus 1. So I know that might seem kind of complicated, but let's do it with an example, and maybe it'll make more sense. So suppose you were collecting some plant, some species of plant, and you grew a total of 6 plants in a controlled environment. And so plant 1 grew to about 9 centimeters, plant 2 grew to about 13, plant 3 to 6, plant 4 to 14, plant 5 to 7, and plant 6 to 11 centimeters. So the average, if you were to average all this together, your x bar would equal about 10 centimeters. So now we want to figure out how spread out is this data from the average. So we can calculate it using variance. So let's first start here. It is some data point minus the average. And we're going to square that and then sum all of them together. So over here I did just that. So I took my first data point, 9 centimeters. So 9 centimeters minus the average, 10, squared it. So before I squared it, that was negative 1. And then when I squared it to get rid of the negative symbol, it was 1. Over here, my second data point, the second plant, grew to 13 centimeters, minus the average, which is 10, so that's 3. And then let me put that square symbol on the outside. But now we have 3, square that, we have 9. Same thing here, our next data point. So data point number 3 was 6 centimeters. 6 minus the average, 10, is negative 4. Square it, we have 16. And so on and so forth. So now that we have all of these, we take the sum. So if you notice over here, so we take the sum of all of those values, sum being the sigma symbol. So if we were to add all these values up, let me zoom out a little bit. If we were to add all these values up, the sum of the xi minus x bar squared would be 52 in this circumstance. So hopefully that made sense. So basically the sum of each individual data point minus the average squared. And then once we have that, we're not done. We need to divide it over the number of data points, your total size of the sample, minus 1. So our size, we had a total of 6 plants that we collected and that we measured. So it would be 6 minus 1. So if we add all of that together, or if we put all that together, we have the variance, s squared, equals 52 over 6 minus 1, so 52 over 5, and that will lead us to 10.4. So that is our variance value. So that tells us how spread out. If we had a lower variance, that means that these numbers were not as far away from the average, so they were closer to the average, so we would have a lower number here, and therefore a lower variance value. So you can kind of see the variance tells us how spread out it is. Now, statisticians, whatever. So, statisticians basically decided that variance are not good enough, or variance values are not good enough. We want maybe some smaller values, and that would also make sense because all of these values we squared, right? So we kind of inflated the numbers. So what we might do instead, well, now that we have this value, is we can find the square root of it. So because we had that square value, we can take the square root, and that's where standard deviation comes in. So we have our standard deviation is our variance squared. And so if we think about our variance calculation, because we were seeing how far away is our data from the average, and we squared that to get rid of the negatives, we're now going to take the square root of it, and that will give us a better number to work with. Ooh, let me grab a different marker. So that will give us a better number to work with. A slightly smaller number within our data range. So this is our final standard deviation from the data that we collected. And because standard deviation is kind of proportionate to variance, if we have a high variance, we're going to have a high standard deviation. If we have a low variance, we have a low standard deviation. So that both of them say essentially the same thing, how spread out our data is. So now let's say we hypothetically were to plot our data on a graph. So we would say our plant height, so for this particular species of plant, we had our data. We found the average to be about 10 centimeters. Now, our standard deviation bars tell us how spread out the data was. So because we had a standard deviation of 3.22, it's 3.22 greater than our average, and 3.22 less than our average. If we had the data points closer together, it would still give us the same average, except our standard deviation bars might look something like this. And that would tell us that our data was less spread out. So we had the same average, but our data was closer to the average than our data was that we showed earlier. So that is standard deviation. These are standard deviation bars, and something that's perhaps more commonly used than standard deviation when it comes to bars like this would be standard error. So that is what I'm going to talk about in the next video. So stay tuned.